So the question says a stone is dropped from a building of height that reaches time t on the earth. On the same building, two stones are one thrown upwards, one thrown downwards. Time t1, t2. And what is the okay, got it. So from here, a stone is just dropped. Okay. So what is the equation? Let's say the height of this is h, which is given already. So what is the time taken to reach the ground? Free fall, just free
Yes.
fall. How will we
2h
do it?
by g whole root.
H is equal to 0 plus half gt square, right? So 2h by g under root.
Mm.
Or let's use this equation. Let's call it the first equation for the first equation, okay?
Okay.
This is in terms of t. Now, when it is thrown upwards, upwards first, no, then it is t1. So for that, once again, even if it is thrown upwards, the displacement from the initial to the final position is still h only, right? But
Mm.
but think about it. So let's see. This is a good concept for understanding frames of references. Whenever you solve any question, you must we directly do it because we are so confident. We take upward direction as positive, downward direction as negative. So you have to be really careful. Which direction are you going to choose, positive and negative? So let's say I'm choosing the upward direction as positive, downward direction as negative, right?
Yes.
So if it goes up, forget about what is happening in the upward. Ultimately, it reaches the ground, right?
Yes.
So
Yes.
from the initial to the final position, what is the displacement? The displacement is actually minus h. Even in the first case, the displacement is minus h, but there is minus half gt square. They got cancelled, and that's why we are getting h is equal to half gt square. Are you getting it?
Yes. Sir.
Now in the second equation, we'll have to take care of it very carefully because there's a velocity involved also, right? Uh,
Okay.
because it is being thrown upwards now with some velocity.
Yes. Yes. Sir.
Okay, so minus h is equal to, this time it is thrown upwards, so plus vt, t1,
Mm.
not t1, because the total time taken is t1, okay?
Mm.
This time is total time, not the topmost time. I'm not
Yes. Sir.
dividing it into two parts. I'm taking the overall journey. Okay.
Yes. Sir.
S, the displacement, which is minus h, is equal to u into total time taken minus half g t1 square. That's my equation number two.
Mm. Sir, in
Okay.
the equation number one,
Hmm.
here they said that from the same building, if two stones are thrown.
Hmm.
So now, when they're saying thrown, shouldn't we consider even the downwards when they're throwing it down with some velocity?
Yes, yes. So that's where coming on. This was the
But we
very
took half
first.
GT square, which is a free fall.
This is free fall for the very first case. There are three cases. We are coming to the third case now. For the third one, it is when it is thrown downwards. There are three cases. You forgot the first part. The stone is dropped from the building
Okay,
and
okay.
it reaches in t seconds. There are t, t1 and t2. Three cases, okay? So that's why I've written t here, t1 here. Now I'm going to write t2, okay? Now it is
Okay.
thrown downwards, but it's in the downward direction. So it is minus vt1
Mm.
and minus half gt square because the acceleration is still downwards. And it
Mm.
will not be t1, it will be t2. Getting it?
Mm. Yes, sir.
Now I have to manipulate these three equations to get a relationship between t1 and t2. Okay?
Yes, sir.
How do we do that? So that this part will be tricky. So let's think what to do. Yeah, let's multiply the second equation with t2 and third equation with t1. Let's do that. So I'm going to multiply it with t2. Look at it really carefully. T2, t2, t2. Got it?
Mm.
t1, t1, t1. Cool.
Yes, sir.
Now I will let's just add them. Let's just add them. Do you see that this and this will get cancelled totally?
Yes, sir.
And this will get added. So minus h within bracket t1 plus t2 is equal to, here also minus half g t1 t2 will be common, half g uh, t, how much will be common? T1 t2 will be common, right?
Mm.
T1 t2, and within bracket it will be t1 plus t2. Do you see this?
Yes, sir.
Check this out. Did you understand this part? Let me know.
Yes, sir.
Okay, so minus and minus go away and t1 plus t2 also go away. Getting it?
Okay.
Now instead of this h, can I write half gt square from the first equation? So half
Mm.
gt square is equal to half, on the right hand side, half g t1 t2. So half g go away. T square is equal to t1 t2. T
Yes.
square is equal to t1 t2. Any doubts?
No, sir.
You just had to manipulate the equations to get your answer. That's all. Sorted?
Yes. Yes, sir.
That's about it. So be confident in such kinds of questions. Try to solve them super quickly. Don't waste times.